So let me share my screen. All right, so today we're looking at conditional probability and how to calculate, and how to calculate conditional probability. Okay, so things that we've looked at so far. We looked at how to notate probability. For example, here you see a P with an A. That's basically the probability of event A occurring. P with a B is the probability of event B occurring. P with this symbol is the probability of A and B occurring. An easy way for you to remember what this symbol means, this symbol right here, is if you think of the letter and, that symbol matches right there, how that N goes. And so that's an easy way to remember that this is when A and B occurs. So both of them occur together. This symbol, however, is A or B. So you're able to differentiate between those two. So that notation is A and B, the probability of event A and B occurring. And then the second one's the probability of A or B occurring. Okay, questions about this? So this is just how we notate these things. Okay, what we're going to look at today is how to notate conditional probability. Conditional probability is the probability that a specific event will occur given that another event has already occurred. So that a specific event will occur given that another event has already occurred. We notate this by probability and A, and then that symbol B. So that symbol represents our conditional probability. This is read as the probability of event A occurring given that event B has already occurred. So probability that an event will occur, given, sorry, what did I say? Event will occur given that another event has occurred. Okay, so this section, the last section, is the event that has already occurred, and this section is the event that we want to occur, the probability that event will occur given that something has already occurred. Okay, so that's how we represent conditional probability. And so we're going to go ahead and look at an example of conditional probability. This says a survey of incoming freshmen is conducted to see whether students would rather take Spanish or French as their second language. The results are given below. So Spanish, 16 males decided that they would take Spanish as a second language, 12 females decided that they would take Spanish as a second language. For French, 13 males decided that they would take French as a second language, and 15 females decided that they would take French as a second language. So this is asking us to find the probability that a random selected incoming freshman is a female given that she prefers Spanish. So whenever we see given, that is our event that has already occurred. So given that she prefers Spanish. So given that someone has already selected Spanish, what is the probability that that person who has selected Spanish is a female? That is what this is saying. So given that that person prefers Spanish, so given that someone has already selected Spanish, what is the probability that that person is a female? So that's how we notate it. Okay, so that last part is going to be that event already occurred and what we're trying to calculate, the probability that it is a female. Okay, the way that we go ahead and calculate this is we want to calculate all those people who have selected Spanish. So 16 males, 12 females have selected Spanish. So that's 28 individuals in total. 28 individuals in total have selected Spanish. Now I want those people, the people who have selected Spanish, to be female. So I want females who have selected Spanish. I have 12 females who have selected Spanish. And so now I can just simplify that as 3/7. Okay, so that's how we calculate conditional probability. Basically, here we want every single person who has selected Spanish, and here we want those females who have selected Spanish. So basically, I could represent this a little bit better if I wanted to, as female who selected Spanish. So not all females, but females who selected Spanish. That's what I'm looking for. Bye. Monday. Okay. And so that is how we calculate conditional probability. Okay. So there's another formula that we can have for conditional probability. So we know that conditional probability is notated as P, event A, given that event B has already occurred. The probability that event A will occur, given that event B has already occurred, right? That's how we represent probability. Well, we can calculate probability by taking the probability of event B occurring over the probability that event A and event B will occur. Okay, so we're going to use this formula to calculate conditional probability. And so we're going to look at an example of this. And we use this if we have a Venn diagram. So given that we have a Venn diagram, we can calculate conditional probability using this formula. So here's a Venn diagram, which means we can use this formula to calculate conditional probability. So this says a pet store has 15 puppies. So there's a total of 15 puppies distributed in this diagram. 9 of the puppies are male. 8 of the puppies are terriers. 6 of the terriers are male. A puppy is chosen randomly. Given that the puppy chosen is male, so that's my given. That's what has already occurred. Given that I have a male, what is the probability that it is a terrier? So given that it's a male, what is the probability that it's a terrier? Specifically a terrier male. Right, because I'm going to take my total number of males and look for, out of all of those males that I have, what is the probability that that male is also a terrier? That's basically what I'm looking for here. Okay, remember that given, if you say given something, that's going to go, that event has already occurred. And then you're looking for what is the probability? That's the event that we're going to see can occur, or what will occur if that has already occurred. Okay, and so we're going to go ahead and notate this. I'm just going to simply change, I can do it over here so you can see. So I'm going to change it. This is probability male. Or what is the probability that it's a terrier male given that it's already a male? Given that we're selecting from those who are already males. Terrier. I'm going to go ahead and substitute these things in so we can work with them. Male. Male. So basically, I'm just going to ahead and replacing those A's and B's, given what I just wrote down as my conditional statement. Okay, so there we go. So now I have this equation, which will help me find my conditional probability. Okay, so now I'm going to go ahead and plug in what I know. What is the probability that I have a male? So what is my total population that are males? 3 plus 6. 3 plus 6 is 9. So those are the total amount of puppies that I know that are males. Now I want them to be terrier and male. Remember that we represent this part would be the intersection of terrier and male. So this would represent the probability of terrier and male. Right, that's how we represent and in a Venn diagram. And so here would be those terriers and male, and so that's 6. Okay, and then now we can simplify this further. 2 over 3. So using a Venn diagram, if I wanted to calculate the conditional probability, I want to use that equation right there. That equation will help me find the conditional probability. In this instance, what is the probability that I have a terrier who is a male? Okay, so you're just plugging in the information given in your Venn diagram into that equation. Okay, questions about this? Okay, we're going to look at some other examples. This says, at East High School, 50% of students have a part-time job. Which is represented by J. That's what it tells me right there. So J, the probability of J is 50. 50%, so I'm just going to put it as a decimal. 40% of students are involved in extracurriculars, which is represented by E. So probability of E is 40%. I'm just going to represent that as a decimal. 30% of students have a part-time job and are involved in extracurricular. So that is the probability of J and E is 30%. Okay. So there I have written down all my different probabilities that I've located. So now, given this, I want to solve this information. What is the probability that a student is involved in extracurricular activities given that the student has a part-time job? So remember, your given goes after. So probability that student is involved in extracurriculars. Probability E given that they have a part-time job. So that's how we would write it. Remember that your given goes after your symbol. Okay, so that's how we would write that one. This one was a probability that a student has a part-time job given, remember your given goes after your symbol, given that that student is in extracurricular activities. Okay, so you can see how we would notate that as a conditional depending on the way this is written. So given always goes on the second part. You see given, then this part that is after the given goes after the symbol. Okay, so that's how we create these. Now what I want to do is I want to calculate my conditional probability. So I'm going to use this equation and see what I can gather from here. So I'm going to replace this stuff. So this is J and this is E. So this is J, this is E. This is J. So I'm just going ahead and I'm replacing it. And then I'm going to plug what I know in. Oh, keep that as P. There. Okay, so that's my expression. Now I'm just plugging in what I know. What is my probability of J? Well, that's right here. My probability of J is 50, so I'm just plugging that in. What is my probability of E and J? Well, this is the same thing. Okay, that's interchangeable. It can be E and J or J and E. And so I'm just plugging that in. And then that's what I'm calculating for. That is approximately 0.60 or 60%. Okay, so what I'm doing here is first I'm writing my conditionals, and then I'm plugging in that information into my conditional statement and then using that to solve. Or putting it into my conditional formula and then using that to solve. So I'll move this over here. Or sorry, I'll move this. But I need to change it around. Because now I have the probability of J given E. So what is the probability of J given E? This was J changed to J. And these will change to E. So now you can see it's a little bit different. But I still have the information to solve. So what is the probability of E? Well, here I'm told the probability of E as 0.40. What is the probability of J and E? Well, there I'm told it's 0.30. So I can just solve for that. That is 0.75, which is approximately 75%. Okay. So in these types of problems, what you want to do is you want to use your word problem to create your conditional statement. So here is this conditional statement, and here's this conditional statement. Once you have your conditional statements, you want to go ahead and substitute that into the conditional formula, which is what we did there, and then you solve given the information you're given. So here you're told that the probability of J is 50, and so I'm plugging that in. The probability of E and J is 30, so I'm plugging that in and then solving. The probability of E is right there. I'm plugging that in. The probability of J in E, right there, and I'm plugging that in and solving. Okay? So basically, we can use this equation to solve for the conditional probability. Okay. Questions about this? Okay. So we're also going to look at the general multiplication rule. This one's pretty straightforward. Basically, what we do is we take this conditional probability equation that we have, and we can create another equation out of this. which basically if we multiply by the probability of B on both sides, that gives us this equation right here. That we can use to solve for the probability of A and B occurring. Okay. So, the general multiplication rule states that the probability that two events A and B will occur can be calculated using this equation right here. This can also be written as the probability of event A occurring times the probability of A occurring given that B has already occurred. So basically, we can use this equation to solve for the probability that A and B will occur if we are asked to solve for that. Okay, so for example, this one said, Edward chooses 2 cards from a standard deck without replacing them. What is the probability that the first card he chooses is black and the second card he chooses is red? Well, if you think about cards, the total number of cards in a deck are 52. Okay. And half of the decks of the cards are red. And then half of the deck of the cards are black. So that's just what we know about cards. And so if you wanted to, you could simplify this to be 1/2 of the cards are red and 1/2 of the cards are black. Okay. So that's what I know. That's what I'm given in the statement. This is asking what is the probability the first card he chooses is black and the second card that he chooses is red. Well, the way that we calculate this is pretty simple. The first thing I want to do is what is the probability the first card he chooses is black? So it's 52 over 26. If he's going to choose a black card, he's going to choose out of the 26 black cards. There's 52 total cards. He's going to choose out of the 26 black cards in order to choose one black. So the probability of picking a black card is 26 over 52. Okay? I'm going to multiply that by the probability that the second card is red. So the second card is red. However, what you need to keep into consideration is that he does not replace them. So think about all his cards. He's already taken away one black card. In my first scenario, he's already taken away one black card. So one black card used. Okay. That means now I have 51 cards left, right? Because I've already taken away one black card. Now, given that I have 51 black cards left, how many red cards do I have left? Well, he hasn't taken away any red cards. So I still have 26 red cards. Okay. So this would be, okay, now I use one red card. Okay, so whenever you're calculating this probability, what you want to make sure is pay attention to this. He takes out the black card without replacing it. So that means now I have 51 cards. I don't have 52 cards because I've already taken out that one black card. Now I have 51 cards, but I still have 26 red cards because I never took out a red card. I took out a black card, but not a red one. And so here, I can go ahead and calculate the probability of this occurring. I basically just multiply straight across. Wait 1 second. 26 times 26. 676. 52 times 51. 2,652. If I simplify this, I get that it is equal to 13 over 51. So that is a probability that first I pick a black card, then I pick a red card. Okay, so whenever you're working with this type of scenario where you have multiple events occurring without replacing the current event, where one event impacts the other event, obviously, then all you're going to do is you're going to multiply those two events occurring. So you're going to multiply the probability of the first event occurring times the multiplying the probability of the second event occurring. Okay, and then that leaves you with your probability of those two events occurring. Okay. So that's how we calculate these types of events. Okay, next thing, final thing we're going to look at is we're going to review independent events. Independent events we discussed are events in which the outcome of one event does not affect the outcome of another event. So this would not be an independent event because once I pick out one black card, it affects the number of cards I have in my second event. Okay? In independent events, the event of one thing occurring does not affect the other things. For example, we saw that if you toss a nickel and you toss a penny, tossing a nickel and a penny does not affect whether I get heads or tails on both of those quarters or both of those coins. Right? Me tossing a nickel after a penny doesn't affect whether or not I get a heads or tails on the first penny. So those are independent events. So two events A and B are independent if when I calculate the conditional probability of A occurring after B has occurred, it is equal to the probability of A occurring by itself. So if I get that my conditional is equal to the probability of A, then I can say that those two events are independent. So for example, here I'm going to see, are these two events independent? And if they are independent, then these two things are going to be equal to each other. So it says Derek has a total of 20 tiles, 8 of which are white and 12 of which are blue. Of the 20 tiles, 2 of the tiles have stars and 3 of the blue tiles have stars. Are the event tiles with the stars and tiles that are white independent? Okay, so I'm going to go ahead and quickly map this out so you can kind of see what they're saying. They're saying I have white tiles and I have blue tiles. Okay, I have white tiles and I have blue tiles. I have 8 tiles which are white, so a total of 8. And I have 12 tiles which are blue in total. Of the 20 tiles, 2 of the white tiles have stars. So stars, no stars. So of my total white tiles, 2 of them have stars. And 3 of the blue tiles have stars. So of my 12 blue tiles, 3 have stars. That leaves me the rest with no stars. Like that. Okay, so that's what I can take from this information. Of the white tiles, how many have stars? How many have no stars? Of the blue tiles, how many have stars? How many have no stars? Okay, what I want to go ahead and calculate here is I want to calculate the probability of me, given that my tile is that it will have stars on it, and what is the probability of just having stars? And if those two are equal to each other, if those two probabilities are equal to each other, then these events are independent. So what is the probability of me having stars that are white? So what is the total number of white? I have 8 total tiles which are white, 2 of which have stars. I have 8 totals that are white, 2 of which have stars. Okay, that's how I write that probability. How about the number that have stars? What is the total number of tiles which have stars? Well, I had 20 tiles to start with. And then I can see here 5 of which have stars. Okay, and so now I want to go ahead and simplify these. This is equal to 1 over 4. This is also equal to 1 over 4. And what I notice is this probability is equal to this probability. And so therefore, since the probabilities are equal, these events are independent of each other. So that's how you calculate independent event. Okay. Again, how do I calculate the probability that given I have all my white tiles, given that I have a tile which is white, it's going to have stars on it. That's what this is saying. You want to take the total number of white tiles, which is equal to 8, over the number of white tiles that have stars. So white tiles that have stars, which is 2. Okay. Given the probability that a tile has stars, well, I have 20 tiles in total. That's what it tells me right here. Total of 20 tiles. How many of those tiles have stars? Well, that's equal to 5. And so that's how I get those probabilities. And then now that I have those probabilities, I want to simplify them. And because these two probabilities are equal to each other, this is equal to this. then I can tell that all those events are going to be independent of each other. Okay, because according to what I know about independent events, the probability of my conditional has to be equal to the probability of that event. In this instance, event A occurring, or event stars occurring. Okay. So what we looked at today was we looked at conditional probability, how to calculate conditional probability. We used the equation. This equation right here. So conditional probability is the probability that a specific event will occur given that another event has already occurred, right? And we remember that we write our conditional as the event will occur. We can say that this symbol represents given that an event has already occurred. Right, that's what our conditional is. The next thing that we looked at was that the probability that two events A and B will occur, we use our multiplication equation, which looks like this. And then lastly, we learned that two events A and B are independent if whenever we calculate the conditional, it is equal to the probability that an event will occur. So if my conditional is equal to my probability, for example here, my probability that given that event B has occurred, I will get A is equal to the probability that I will get A by itself. Okay, so that's how we calculate independent events. For these types of problems, it's just going to ask you, are these events independent? And the way you calculate it independent is you want to make sure that when you calculate the conditional and you calculate the probability of that event, that you want those two probabilities to be equal to each other. Okay. Now, I know this is a lot of material. I will go ahead and post a brief cheat sheet. Basically, what is the overview? What do you need to take away? But I will not see you guys tomorrow. But if you do have any questions, just feel free to email me. Okay. Okay. If there's no other questions, you guys may log off. And I will see you guys on Monday. Bye, guys.